today we will be comparing populations in data sets. Okay, the double line plot shows the weights in pounds of several house cats and small dogs. For the house cat, the mean and median are 11. The range is 4 and the interquartile range is 2. For the small dog data, the mean and medians are 9. The range is 6 and the IQR or interquartile range is 2. Compare their centers and variation. What are some appropriate inferences we can make about the data? Okay, so the mean and medians are both the same for them, which means that their data is symmetrical. Okay, see how this data looks the same on both sides of the center? Okay, that means they're symmetrical, which means your mean and medians are the same. Okay, so the mean and median for the house cat is greater than the mean median for the small dog. Okay, the weights of the house cat are larger than the mean weights of the small dogs. Okay, and then the range of house cats is 2 less than the range of small dogs. Okay, so those are some things that we can uh, assume or notice about the data. Those are some comparisons that we can make. Also, the interquartile ranges are the same for these. Okay, so we can see that the variation for small dogs is greater than the variation for house cats. Okay, based on this data, it just means that it's spread out more. Okay, all right, let's take a look at the second one here, the double box plot. All right, now the box plot, remember, shows you the medians, the minimums, the maximums, and then you can find your interquartile range by subtracting both of your upper quartile range or upper quartile median and your lower quartile median. Okay. This is for the number of calories per serving for fruits and vegetables. What are some appropriate inferences we can make? Well, we can say that the range of calories in vegetables is smaller than the range of calories in fruits. Okay. And I would say generally the calories for vegetables are going to be lower than the uh, average calories for fruits. Okay, so the average calories for your vegetables is less than the average calories for your fruits. Okay, so those are some things that we can assume about the data. All right, now let's take a look here. Stem and leaf plots. Reminder, stem and leaf plots. This number represents 3 because 0, 3 is 3, then 4, 5. This was 10. 1 0 is 10. 1 5 is 15. 2 0 is 20. Okay, so the stem and leaf plot and table represent average number of hours of homework for each week for high school students and middle school students. Use the measures of center and variation of these samples to select the age group to which each statement applies. Okay, so the median is greater. All right, so we need to find the median of the middle school and then the median of the high school. And they did list the high school in order from least to greatest, so we can easily find that middle by crossing out and going 8 is going to be the median, is 8. Okay, and then we're going to do the same thing here. 1 2 3, 1 2 3. Then we do from either side in order to find my median would be 7. Okay, so the median number of hours studied for the middle schooler is 7. The median number for high school is 8. So it is greater for the high school. Okay, and then the interquartile range is 4.25. So we can actually see here that if 8 is my median for here, I would need to find the median of the rest. So I have 2, 2, 1, 1. So the median of my lower quartile is 7, and the median of my upper quartile is going to be, so we've got 2, 2, and that's going to be 10. So 10 minus 7 is 3. So that's going to be for high school. And then if I look at the middle school, find the median of my lower set of data is going to be 5, and the median of my upper set of data, median here is actually between 6 and 7, so the median is actually 6.5 on this one. Okay, when your median is between two numbers, you include each number in the lower set and the higher number in the higher set of data. So when you're finding median of each of them, we need to include that. So 2, 2, 3, 3, 4, 4, which makes 5, the median of the lower set. And then we would have 7, 7, 1, 2, and then there's 3 9s. So this 9 would be here. So I have 4, 9 minus 5 is 4 as my interquartile range. So neither is 4.25. Okay, middle school is 4, and high school had an interquartile range of 3. Okay, so the middle half of the data has less variability for the high school, okay, because their interquartile range is only 3, whereas the middle school is 4. So their variability is higher, okay? A person from this sample is more likely to have more than 8 hours of work. Okay, a sample is more likely to have, so high school is more likely to have more than 8 hours of work. Okay, a person from this sample is more likely to have less than 7 hours. Okay, the median is 6.5, so middle school would be more likely to have less than 7 hours. Okay, so you have to go through and find all of that information and determine whether that applies to each set of data. Okay. All right, the double box plot shows the number of rainy days for each month, a year for 2 different cities. For which city is it more likely that a randomly selected month will have 6 or more rainy days? Okay, and we can see here in these box plots, remember the median here represents 50% of the data. Okay, so the median for city A is at 6 days or more will be rainy. So 50% in city A will have 6 or more rainy days, whereas in B, 6 or more rainy days, it's only 25%. So city A is more likely to have 6 or more rainy days, okay, because 50% of the time it's 6 or more rainy days in a month. Okay, now let's take a look at double line plot shows the number of years of experience playing lacrosse for members of 2 high school lacrosse teams. A player with 6 years experience is on a lacrosse team. On which team is the player more likely to be? Okay, so if we look at this, the middle of our data here is at 6 for the Somerville Jaguars, whereas the middle of my data for Southwest Broncos is at 5. So it says with a 6 or more years experience, well, 50% of the data is 6 or more years experience for the Somerville Jaguars. So it would be more likely to be on the Somerville Jaguars because over half the data is 6 or more. So hopefully that helps walk through how we compare sets of data when it's represented in different ways.